Hi, welcome to Live Life Ravishingly. Today, we're continuing our AI journey with Mr. Shivaram, and we'll speak about LLMs today, large language modules. Welcome to my show, Shivaram.
Thank you, Rajesh. Glad to be here.
Thank you. Now, Shivaram, tell me, what exactly is LLM?
Okay. Uh, as the name indicates, Ravish, large language models, LLMs, are in the hype today. And essentially, they are language models.
Okay.
Language model is something which understands the language.
Okay.
It is a type of deep learning model based on a particular architecture called transformer models, transformer architecture. Okay, what it does is it learns how to generate the text as if a coherent person is talking.
Okay.
Like for example, so large language models are trained in multiple stages.
Okay.
The first thing people do for training large language models is they amass huge amount of data.
Okay.
All internet data, like whatever you can get, they will take it. They will probably hack people's computers and take
Data. Yeah.
data and so on. So the people are amassing huge amount of textual data, and this data is then processed to remove unwanted things. So
Right.
on the internet you have a lot of unwanted stuff, right?
Correct.
So bad things as well. So you have to remove it because
Correct.
or else your model will learn that.
Right.
So you remove that, you clean it up, and the internet data is in the HTML format. You have to convert it into text format and so on. So once you get the text, okay, this text is then converted into tokens. Okay, and then we feed all of this information into the LLMs so that once the model learns how to generate the next token based on all the training, so we get something which is coherent. Like if we start something, it will start continuing from there. Okay, so that's what we get.
Okay. So you spoke about tokens. So what exactly is tokenization?
Okay.
Can you explain in more deeper way?
Okay. Tokens, we need to understand that machines don't understand language, right?
Yeah.
We understand language, and for us, each and every words, we understand each and every words, right? But that is not the same with models, AI models, and the computer per se, right? They see everything as numbers.
Yeah.
Okay. For computers, everything is numbers.
Zeros and ones.
Zeros and ones.
Yeah.
Now, how do you store all this text in a way to train the AI model, right? You can store it in terms of words. You can store it in terms of characters. You can store it in some other way as well. Okay. But what people found out is to store the things based on something called as the root words. Like for example, bowling. It can be bowl and ing. Ing is something which occurs commonly, so you can reuse it in other places.
Got it.
And bowl is something which is there, like which is a concept which can have its own token. Token means its own number, unique number. Okay, ing will have its own unique number. And then if a particular thing is starting with a space, the king of Egypt, let's say, D becomes one token. Space is becomes another token.
Okay.
And so on.
Okay,
right?
got it.
King becomes another. Space king becomes another token, and so on. So what you are trying to do is tell the computer that there is this word which is coming, and this word has this number associated with it, and that is the token. Okay. Larger words are broken into mostly 2 to 3 tokens. Smaller words are single token.
Got it.
So if you have 1,000 tokens, this is the approximate understanding. 1,000 tokens is one A4 sheet of text. So, and if you today see large language models, the pricing is also based on the number of tokens. Number of tokens which are input and number of tokens which are generated as output. Output is normally more costlier than the input. And the pricing is per million tokens. They will say per million tokens, it is $2. Per million tokens, it is $0.14, whatever, right?
Got it.
So that $0.14 per million tokens is basically the pricing for using that model.
Got it. Okay. So now I got something into my mind. So how to make these LLMs think?
Okay. So it's a good question.
Thank you.
I think already know LLMs don't think. That is the reason you're asking this.
Yeah.
What happens with LLMs is when during the training of LLMs, we basically do the first step, which is we make the LLMs generate text.
Yeah.
Just you start with some text and it starts generating the next words, predicting the next words. Okay. If you ask a question like, what is 2 plus 2? It should basically say the answer is 4.
Right.
The sum is 4 and things like that. But in the first step of training, you have trained it on entire internet knowledge, how to generate the next sequence. So it doesn't know that it has to answer the question. So when you ask a question like 2 plus 2 to a LLM, it may not answer the question, right? To do that, you go to the second phase of supervised learning, where we give huge number of examples of questions and answers, how user will ask the question, how the answer should come from the prompt, from the AI, right? From the LLM. By seeing that examples, it quickly learns that, okay, though I have learned all this next generation token generation thing, I should not just generate it as I want. Someone is asking question, I have to answer it. So that is trained in the second part. Okay, that is called supervised learning. And then the last part is the third part of the training is the reinforcement learning, where we make the quality of the output good and make it think in number of steps. So as I told you, deep learning is all about breaking a problem into multiple steps and solving the problem, right? AI is not good at solving everything at once.
Got it.
Right? Like humans as well. Like, very few people can answer immediately. They want to break it down into steps and solve the steps, right? Similarly, LLMs also need to do that, and reinforcement learning is a way to train the models to get to the correct answer by going through the right steps and so on. So the training happens in 3 stages. Now, in all these 3 stages, there is no thinking process. It is just generating the next token. Though we have trained it to think in steps, that is, break the problem into steps, it is basically trying to generate tokens which are of lesser difficulty, and using that, it's trying to get something which are lesser difficulty and so on. And when you combine everything, it is able to solve a tougher problem.
Got it.
So if we get more number of such simpler steps, that is the thinking of LLM for today, right? It doesn't do planning like us. So all the planning has to be generated by it. Now, if you today use OpenAI's O1 model, or if you use DeepSeek R1, right? What it does, it does the thinking, okay, then generates the output, right? It is not doing that thinking for you. Okay, it is not to show you, oh, you can think like this, then you'll get that. It is doing the thinking for itself to solve the problem.
Got it.
It is breaking down the problem into smaller parts.
Got it.
Okay. So right now the thinking is happening during the inference phase. That is when you are using the model, when you are asking the question, it is getting some additional context into that so that it can simplify the problem.
Got it.
Break it down.
Got it.
So that is where the thinking is happening and is helping. Another way of thinking is giving documents additional information to it, where it can go when you ask the question, it can go fetch the information from there, from the data, and get it, and then solve the problem.
Okay, got it.
Okay.
So Shivaram, tell me, which is the best LLM available currently, and who are the players?
Okay. The best LLM model even today, this is as of Feb of 2025, is OpenAI's models.
Okay.
OpenAI's O3 is considered the best model. Okay. And the O3 mini is available today.
All right.
O3, the main model, is not available. It is said that it runs for a huge amount of time. It spends more than $1,000 to run, just run. Okay, and it's very powerful. O1 Pro is what I've used, and I've seen O1 Pro with deep research is really good.
Okay.
So what deep research does is it goes to the internet and gets information, uses that information to solve a problem. So it is very powerful. Apart from that, there are various other players. Earlier, the difference between OpenAI and others was huge. Now it has reduced a lot.
Got it.
Now DeepSeek R1 is pretty good.
Yeah.
Really good.
Absolutely.
And it is open source, so it's crazy good. Everyone should take that model, modify the way they want and use it. The second is, I feel it is DeepSeek R1, though other people claim their models are best and so on. Then you have Anthropic, which is a company which has this set of models called Claude. They are also good.
Great. Okay.
Then you have Google.
Of course.
Google's earlier Google's models were not so good. Now the thing what Google is doing is giving the models at a very low price. Google, Gemini Flash is very good. There were the 2.0 versions. They're pretty good and they're fast.
What about Microsoft?
Microsoft has partnered with OpenAI, so they are using OpenAI models in their this thing. They also have other models, Phi and all those things, Phi 2, Phi 3, and so on. They are smaller models.
Got it.
They are used for specific business cases and so on. Those models are good. Okay.
You spoke so much about LLM, etc. How to use this LLM? That's the important question I have.
Yeah, so LLMs can be used in various places. It can be a separate video on its own because there are so many use cases. I'll just name few.
Okay.
It can be used as a chatbot.
Yeah, right.
Conversational agent.
Absolutely. Most important.
It can be used in the field of education, healthcare, finance, you name it, where people have to have a conversation as if they're having with humans.
Right.
These models are so close to humans today, it is almost indistinguishable. And they are so robust that no human can think of all the things what AI model thinks, but they lack certain things. Like, for example, they may not know the context properly, or they may not give you the right answer because you may know something which they don't know, and things like that. But if they know everything what you know, they more or less get the answer with generic IQ. I call it as generic IQ because they are able to tell you everything which is needed for solving that. They may not do that super thing which few people are like someone really smart works on it and spends half a day on it. They may come out with a eureka moment that they may not do.
Correct.
Apart from that, all the generic stuff they are doing very well.
Great. So we learned a lot about LLM and it was really great. Thanks, Shivaram, for joining my show.
Thank you, Ravish.
We'll continue our journey with AI and with our intelligent guy, Shivaram. Stay tuned. Thank you.
Thank you.